At the break of dawn in the Amazon, long before sunlight pierces the mist-wrapped canopy, a single sound splits the stillness, guttural and low, like the echo of tectonic plates grinding in their sleep. It's not a roar. It's not a scream. It's something deeper, primal, mechanical, as if the forest itself is drawing breath through a torn speaker. The call belongs to the alouatta, known to the world as the howler monkey, but to the elders of certain remote tribes, it's something else entirely. A sentient alarm system coded into the jungle's architecture by hands no longer remembered. Biologists classify howler monkeys as New World primates, a branch of arboreal leaf-eaters with prehensile tails and relatively slow metabolisms. On the surface, they are modest creatures, thick-furred, heavy-jawed, often lethargic in the afternoon heat as they digest fibrous vegetation in the high canopy. But as any field researcher who has camped beneath their trees will tell you, these primates possess one of the most extraordinary biological adaptations on the planet. An enlarged hyoid bone, a hollow chamber of bone and cartilage in their throat that functions like a resonance chamber. Through it, their vocal cords can produce low-frequency calls that travel for up to 5 kilometers, cutting through the forest with near supernatural force. Unlike most vocalizations in the animal kingdom, the howler's call doesn't simply warn or attract. It penetrates. Field data has confirmed that the fundamental frequencies in a howler's bellow range between 300 to 500 Hz, but it's the subharmonics, those infrasonic rumbles beneath conscious hearing, that unsettle experienced biologists and provoke unease even in seasoned trackers. These frequencies have the capacity to affect the autonomic nervous system in humans, triggering cortisol responses, disorientation, and in some cases, panic. People have reported nausea, cold sweats, and short-term visual distortion after prolonged exposure. This is no mere territorial cry. It's a neurological event. Ecologically, the howler's voice evolved as a form of energetic economy. With diets composed largely of mature leaves, low in calories and high in toxic alkaloids, these monkeys must minimize movement. Climbing down to confront rivals would be wasteful, even suicidal. Instead, they broadcast dominance from the treetops using acoustic projection, a form of biological warfare where the battlefield is the brain. In this sense, they are the jungle's philosophers, not fighting with teeth, but with resonance. But in regions where anthropology and biology intersect, in the blurred zone between empirical observation and tribal cosmology, a more unsettling narrative emerges. Among certain Ticuna and Jaguar elders, there is the belief that the howler monkey is not entirely natural. Their lore tells of a time when the jungle was an open laboratory, shaped by those who walked before men, beings who understood not just nature, but how to write it. The howler, they say, was one of the first guardians, not built to kill, but to disrupt. A creature encoded to manipulate emotion, to scramble coherence, and to deter intruders from stepping too far beyond the known paths. The idea might seem fantastical, until you consider the reports. In 1986, a joint expedition near the Javari Valley abruptly withdrew after their lead botanist suffered a complete mental collapse. The symptoms mimicked acute onset schizophrenia, auditory hallucinations, violent outbursts, and intense paranoia. Local guides, unshaken by the event, simply nodded. He walked where the monkeys told him not to go, one said. While science might attribute such cases to dehydration, isolation, or tropical fevers, there remains a gap, a hollow, bone-like chamber in our understanding, where biology, psychology, and mythology echo one another. Consider sleep deprivation. The howler's calls begin well before sunrise, sometimes as early as 4 a.m., their cadence escalating like a war chant. For unacclimated humans, this pattern fragments sleep cycles, pushing the body into a perpetual state of low-grade stress. Sleep is critical, not just for physical recovery, but for emotional regulation, memory processing, and immune function. Strip that away night after night, and even the strongest minds begin to unravel. The monkeys know this, instinctively or not. They seldom howl at random. Their calls peak at moments of climatic shift, barometric changes, lunar cycles, even the arrival of strangers in their territory. Some biologists have noted that howler troops will coordinate their calls to flank a group of intruding humans, setting off vocal barrages that confuse direction and distort spatial awareness. In the chaos of sound, trails vanish, orientation fails, and what once felt like familiar jungle becomes labyrinthine and hostile. And then there's aggression. Among the more curious findings in fringe neuroacoustic research is the phenomenon of frequency-linked emotional resonance, the idea that certain frequencies can amplify latent emotional states. A calm mind may resist, but in moments of stress or fear, these frequencies can magnify those emotions, creating feedback loops of anxiety or rage. While not definitively proven in humans, the concept is well documented in lower animals. Could the howler monkey's roar serve not only to scare, but to provoke? Some field teams have reported otherwise calm local guides turning irritable or combative after prolonged exposure. One case ended in violence. In predator-prey terms, the howler occupies a strange niche. Its primary predator is the harpy eagle, a massive raptor capable of plucking primates from the canopy. But even these apex birds struggle to track the monkeys, whose calls are deceptive in spatial origin, bouncing and bending through layers of foliage and humidity. There is a suggestion, too, that jaguars avoid areas of frequent howler activity, not out of fear, but discomfort, as if the sound masks scent trails or disrupts their acoustic hunting cues. Taken as a whole, the howler monkey is not just a marvel of vocal evolution. It is a creature whose existence seems optimized for psychological warfare. Its voice is its defense, its offense, and perhaps its message: you do not belong here. And if the tribal myths hold truth, if some lost architect of the jungle did, in fact, encode behavior into biology, then the howler may be less an animal and more a warning system, still running millennia after its creators vanished. The jungle, in this view, becomes not a wilderness, but a machine. A living labyrinth of sensory cues and behavioral triggers designed not only to hide its secrets, but to protect them. The howler monkey, with its hollow roar and ancient tone, is simply the first circuit you trip when you step too far in. Under the layered quilt of Amazonian canopy, where the light filters in fragmented bands and the air hangs thick with biological tension, there are places even predators tread lightly. It is not the flash of fangs or the warning cry of birds that deters them here, but the presence of a more subtle menace, something silent, nearly still, woven into the very architecture of the understory. At the edge of a rotting log or the crease between buttress roots, she waits. Latrodectus curacaviensis, the South American black widow. Her body gleams like an obsidian bead. Her legs, articulated with impossible precision, move not with the panic of prey, but with the certainty of a mechanism executing code. To an untrained eye, she might seem unremarkable, small, fragile, even forgettable. But to those who have studied neurotoxins, to those who've seen what one drop of her venom can do to a mammalian nervous system, her presence marks a quiet rupture in the rules of natural behavior. The black widow spider is no brute force hunter, she is a neurochemist. And her strategy is not to overpower, but to override. Her venom, latrotoxin, belongs to a rare class of biochemical compounds that do not merely immobilize, they interface. Upon injection, latrotoxin binds to presynaptic nerve terminals and hijacks their machinery, triggering an uncontrolled flood of neurotransmitters, primarily acetylcholine, dopamine, and norepinephrine. This biochemical surge forces the nervous system into a state of chaotic hypercommunication, resulting in muscle spasms, sensory distortion, and in some cases, deep emotional dysregulation. Pain is only the entry point. What follows is a kind of neurological disassembly. Victims, often field researchers, barefoot farmers, or indigenous hunters, have described more than just physical reactions. Some report euphoria, followed by waves of grief or dread. Others speak of vivid hallucinations and strange dreams for weeks after recovery. There are even scattered medical records documenting transient memory loss, altered personality traits, and episodes of emotional detachment. These aren't the symptoms of a typical envenomation. They're signatures of a nervous system that has been fundamentally reprogrammed. In the dense ecosystem of the Amazon, such effects are not coincidental, they are ecological tools. The black widow is a fragile predator, incapable of withstanding direct confrontation. Her evolutionary pathway required something more precise than speed or strength. By targeting the nervous systems of both prey and predator, she built herself a fortress of biochemical deterrence. Most animals learn to avoid her not through experience, but through instinctual terror, inherited memory encoded in scent and posture recognition. The cost of error is too high. A brush with her venom doesn't just scar, it alters. Yet among the ticuna and matses, there are deeper tales. Stories passed through generations that speak of warriors stung by the widow and returning as something incomplete. Their eyes dulled, their loyalties blurred. In the most extreme versions, these men became jungle servants, navigators of strange routes, whisperers of secrets in dialects they'd never spoken before the bite. Such accounts have long been dismissed by anthropology as symbolic or mythic. But modern neuropharmacology tells us something curious. The dopamine surge caused by latrotoxin is often followed by a period of intense receptivity, a neuroplastic window during which the brain is unusually capable of forming new associations, learning behaviors, and integrating stimuli. In medical trials on similar toxins, researchers have observed subjects demonstrating increased suggestibility and altered moral reasoning, at least temporarily. If the black widow's venom opens such a window, then it raises uncomfortable questions about its purpose. Is the bite merely a defensive reflex, or is it a key, a chemical invitation to overwrite? Unlike most predators, the black widow does not consume her prey immediately. Her silk, unusually strong for her size, is woven into chaotic three-dimensional webs with no obvious center. These aren't passive traps, they are suspension chambers, where the spider waits for vibrations that match the specific frequency signatures of her preferred prey. Small insects, soft-bodied reptiles, even other spiders. Upon capture, she immobilizes them not only with venom, but through modulation of movement. Limbs spasm in patterns that suggest not paralysis, but motor confusion. It's as if the animal isn't just dying, it's being rewired. This theory grows more unnerving when considering the venom's effect on reproductive systems. Studies have shown that latrotoxin can interfere with hormonal signaling, sometimes inducing unseasonal mating behavior in small vertebrates. There are documented cases of lizards and frogs, bitten but not killed, entering hormonally triggered states that last for days, affecting their role within local population structures. Whether this is coincidence or an engineered behavior remains unclear, but the implications are significant. The spider's venom may be manipulating not only individual targets but influencing ecological rhythms on a broader scale. Then there is the question of emotional collapse. While the scientific literature often downplays anecdotal reports, dozens of accounts describe severe emotional side effects in human victims. Euphoria during the first 12 hours. Confusion and hypersensitivity for the next 24. Then a phase of crushing melancholy, a neurochemical crash from which some never fully recover. Dopamine exhaustion perhaps, or something more permanent. A rebalancing of neurochemical baselines that redefines what a person perceives as normal. A kind of involuntary emotional reboot. Victims speak of a loss of connection to prior attachments. In more poetic tellings, they say the jungle takes a piece of them and does not return it. Some researchers have speculated that this sequence, pain, euphoria, collapse, creates a loop of psychic dependency. A neuroaddiction not to the venom itself, but to the event of envenomation. In animal studies, rats exposed to synthetic analogues of latrotoxin have been observed seeking out further exposure, even when it caused physical harm. This raises the disturbing possibility that the venom does more than subdue, it conditions. It teaches the brain to want the disassembly. Tribal references to venom-induced obedience may stem from these patterns. In ceremonial contexts, shamans have been said to use venomous spider bites in controlled doses to induce trance states, believing the bite to open the mind to jungle spirits. Whether metaphor or misinterpreted neurochemistry, the outcome is the same. A person made receptive, pliable, spiritually suggestible. In this context, the Black Widow is not simply a spider. She is a tool, a chemical bridge between consciousness and something more primal. In predator-prey interactions, this makes her an anomaly. Few animals evolve such sophisticated methods of indirect manipulation. The venom is not merely defensive, it is adaptive control. And if one accepts the fringe hypothesis that certain Amazonian species were bioengineered, perhaps not by extraterrestrials, but by a forgotten civilization with a grasp of genetic programming, then the Black Widow fits the profile of a directed organism. A micro-engineered agent capable of modulating behavior, triggering emotional resets, and even altering social dynamics. From a purely ecological perspective, the Black Widow fills her role with elegant efficiency. She limits population surges in insect and small vertebrate communities, maintains predator caution in her vicinity, and leaves a minimal ecological footprint in terms of biomass and waste. But layered beneath these functions is the suggestion of something more, a neurochemical interface embedded in the forest's design. A small, silent operator within a greater system, not a guard like the howler monkey, but a programmer uploading jungle code into any nervous system foolish enough to make contact. As we zoom back out from her motionless figure in the shadow of a root cluster, from the tremble of silk catching windless air, from the chitin shine of a body that hasn't changed in millions of years, we're left with the realization that the jungle does not always confront intruders with teeth or sound. Sometimes it whispers in chemical tongues, rewriting not the body, but the self. The jungle here is not flat nor fixed. It pulses. Roots swell with groundwater and collapse with drought. Paths vanish in a day beneath lianas and falling debris. The terrain is dynamic, not only shaped by weather or decay, but by movement. And in this volatile choreography of mud, stream, and shifting light, one creature seems to have written itself outside the rules entirely. When startled, it doesn't duck for cover or vanish into the underbrush. It runs, but not across dirt or stone. It runs on water. The Basiliscus basiliscus, or common basilisk, has earned the nickname Jesus lizard for its remarkable ability to sprint across the surface of rivers, ponds, and swamp pools. But this popular moniker, often delivered with a smile, hides the deeper marvel. This lizard's movement isn't just quick, it is a biomechanical anomaly. A defiance of gravity, a phenomenon that, at first glance, seems to contradict everything we understand about body mass, water surface tension, and locomotion. But within the context of its environment, a biome where terrain shifts like liquid, where predators attack from air, land, and water, the basilisk's gift makes evolutionary sense. And perhaps, in another lens, it makes design sense. Viewed in high-speed footage, the basilisk's movement is mesmerizing. At full sprint, it rises on its hind legs, tail counterbalancing the forward momentum, and slaps each foot downward with enough force to create a pocket of air beneath its toes. These rapid slaps, up to 20 times per second, create a pulsing interaction between water and limb. Tiny fringes of skin along the toes expand with each contact, increasing surface area and distributing the force more evenly. The result is a fleeting but repeatable miracle, temporary lift, like skipping stones controlled by tendons and nerve impulses. The lizard becomes a cipher, not swimming, not flying, but hovering briefly in defiance of gravity's pull. This behavior is, in purely biological terms, an escape mechanism. In the margins of creeks and flooded forest paths, where jaguars stalk and herons strike from above, speed isn't enough. Speed in unpredictable directions becomes a weapon. And the basilisk lizard has mastered it, able to pivot mid-sprint, leap from water to branch, and vanish into vegetation with almost no sound. It doesn't just escape, it erases itself. But in areas of the Amazon rarely visited by outsiders, along the riparian corridors of Peru and southern Colombia, local tribes speak of the basilisk in stranger terms. They do not consider it a simple reptile. In some oral traditions, it is called Yurupari's scout, a creature said to guard forbidden pathways. According to these tales, those who chase the basilisk too far from the riverbank often lose more than their quarry. Some report strange headaches, others temporary blindness. A few, particularly those carrying metal tools or radios, claim their equipment failed or jammed inexplicably during pursuit. Some even tell of dogs refusing to follow a basilisk's trail, turning back with tails down and ears flattened. These reports, dismissed by science as anecdotal, invite deeper speculation when considered alongside what we do know about the creature's anatomy. During rapid locomotion, the basilisk's foot strikes the ground, or water, with a specific frequency. Studies measuring the vibration footprint of their sprint show pulses that resonate between 80 to 130 Hz, low enough to propagate across the water's surface, but high enough to be felt by certain animals sensitive to vibration. Amphibians, insects, and even some mammals exhibit avoidance behaviors in response to these pulses. Could it be that the basilisk isn't just evading detection? It's broadcasting disruption. If these vibrations interfere with directional scent trails or auditory processing, especially in predators like coatysaur ocelots, then the lizard is effectively jamming the jungle's tracking systems. Such interference could also explain the frequency disruption reported by local trackers, particularly when GPS or shortwave devices seem inexplicably scrambled after encounters. While no formal studies have confirmed electromagnetic fields around the basilisk, the coincidence is notable, especially when coupled with their habitat choices. Basilisks seem to prefer riparian borders not just for escape routes, but possibly for reasons related to geomagnetic alignment. In one long-term study in Ecuador, basilisk populations were found to concentrate near naturally magnetized rock formations, a preference not yet fully understood. Another behavior complicates their evolutionary profile: dynamic camouflage. Though less capable than true chameleons, basilisks possess limited chromatophores, pigment cells in the skin that allow them to subtly shift coloration in response to light, heat, and stress. This isn't dramatic color shifting, but more a blending, a dimming or brightening that breaks up the outline of the body against changing backgrounds. In dappled light, where sun and shade flicker constantly, this adaptation becomes incredibly effective. Basilisks have been known to remain motionless for hours, fully upright, blending with vines or river roots, their skin adjusting to the thermal and optical input of their surroundings. In tribal stories, this ability is exaggerated to the point of invisibility. Accounts tell of children bitten without seeing what attacked them. A sudden sting, a flicker of movement, then nothing. Herpetologists may scoff, but a camouflaged lizard striking quickly and retreating before it's consciously registered is not implausible. Basilisks are insectivorous, primarily, but opportunistic. There are confirmed cases of them preying on frogs, hatchling birds, and even small snakes. And their bite, while not venomous, is powerful for their size. Their jaw musculature designed to clamp and crush quickly, minimizing struggle. In terms of evolutionary engineering, all of this points to a design model based on unpredictability, not brute defense, not lethal offense, but terrain mastery. The basilisk doesn't simply inhabit the jungle. It moves through it in ways that evade the standard rules of tracking, pursuit, and retaliation. If we entertain the speculative framework introduced in earlier chapters, the hypothesis of bioengineered organisms embedded within the Amazon's ecological fabric, then the basilisk emerges as a kind of terrain enforcer, a motion-based cipher, a codebreaker that manipulates physics to protect certain zones. Such an organism would serve valuable functions. As a surveillance unit, it would be near impossible to follow or capture. Its motion would signal disturbance across large areas without requiring vocalization. Its ability to interfere with electromagnetic or vibrational sensing could disrupt technology or instinct alike. It could, in theory, protect locations, sacred sites, buried structures, or energy nexuses, not by confrontation, but by dissuasion. And should a trespasser come too close, it would vanish not into the shadows, but into water, untraceable, uncatchable, unrecorded. To this day, long-term observation of wild basilisk behavior is limited. They are difficult to tag, almost impossible to radio track, and rarely captured without damage. They breed seasonally but erratically, often disappearing from one riverbank entirely and appearing kilometers away within a few days. Their patterns resist modeling. Their habitat preferences remain loosely defined. Even in captivity, they exhibit unpredictable stress behaviors, often refusing to eat or bask under artificial conditions, sometimes dying inexplicably within days. It is this unpredictability, more than their water walking or camouflage, that gives them their power. In the logic of natural selection, survival favors reliability. But in a landscape engineered not to evolve, but to defend, unpredictability becomes a feature, not a bug. So when the basilisk darts across the stream, tail high, toes slapping the water with rhythmic intensity, it's not just fleeing. It's transmitting. And perhaps, if the old stories are true, it's also warning. Not you specifically, but the jungle itself. Something has crossed into the wrong place, and the terrain is responding. In the saturated silence of midday, when even the birds have quieted and the canopy breathes heat like a furnace, the Amazon appears still. But beneath the leaf litter and under the shadow of roots solder than memory, a low vibration pulses, faint, steady, ancient. It does not come from wind or river, but from the churning of mandibles, the packing of earth, and the whisper of millions of coordinated limbs. The termites are building. What rises from the jungle floor is more than just a mound. To the casual observer, it's a tower of earth, dry and crusted, unremarkable except for its sheer scale. But step closer. Study the structure with a naturalist's patience or a surveyor's instruments, and new patterns emerge. Buttresses that mimic flying buttress architecture, archways aligned with solstitial sunrise, shafts that follow the contours of magnetic declination. This is not random soil piled for shelter. It is architecture, purposeful, complex, and in some cases uncannily sacred. Termites, specifically the Nasuti termitinae subfamily found across swathes of Amazonia, are eusocial insects whose colonies can number in the millions. Governed by castes, they display levels of social coordination that rival the most sophisticated human cities. Workers forage, soldiers defend, and the queen, massive and bloated, remains buried deep within the central chambers, laying thousands of eggs daily. This in itself is no mystery. What draws scientific intrigue and sometimes quiet alarm is how they build. The mounds these termites construct are not simply places to live, they are machines. Internally, each mound is engineered to regulate temperature and humidity with astonishing precision, despite the unpredictable extremes of tropical climate. Vertical ventilation shafts channel air through chambers packed with fungal gardens, cultivated by the termites themselves, which act as both food source and biochemical filter. External ridges and fluting are not decorative but aerodynamic, redirecting rain and wind to preserve structural stability and internal climate. In essence, the mound is a living air conditioner, data processor, and food farm combined. Yet when researchers began mapping termite mound locations over wide areas, a stranger pattern emerged. In certain regions of Brazil, particularly in the arid transition zones near the Amazon basin's edge, termite mounds were found to be spaced with such regularity and mathematical precision that the layout formed geometric grids. These grids spanned dozens of square kilometers, some aligned with cardinal directions, others mirrored constellations visible only during specific solstices. Still others sat atop subtle fault lines or underground aquifers, as if the termites were responding to geophysical forces far beyond their sensory capacity. Local legends had long hinted at this. Among the Kaxinawa and Shipibo, the mounds are referred to not just as nests, but as points of containment, thresholds that separate clean jungle from old ground. Elders speak of certain termite towers as holding places, constructed around things that should not move or sounds that should not escape. These tales were often dismissed as symbolic metaphors until researchers mapping acoustic propagation in termite-infested regions found anomalies. Inside certain mounds, when exposed to low-frequency sound, chambers resonate at extremely specific harmonic intervals. One study found that frequencies around 110 Hz caused a narrow chamber near the Queen's chamber to oscillate, not structurally but sonically, creating standing waves. In humans, such frequencies can trigger physiological effects: pressure in the chest, altered heart rate, and vertigo. In the controlled echo of the mound, the effect is amplified. One field technician reported mild hallucinations after prolonged exposure. The effect was temporary. The questions it raised were not. Could it be that these insects, through instinct or ancient instruction, are building resonant chambers? And if so, to what end? Are they tuning the jungle like a massive acoustic instrument? Is this sound, this vibration, a form of containment or a message? From a survival perspective, termites have no reason to build in such complex ways. Their mounds could be simpler, and often are in other parts of the world. Yet Amazonian termite mounds stand apart, more durable, more aligned, and more geometrically structured than those found in Africa or Southeast Asia. The behavior is not universal, but regional, concentrated in areas of known ecological richness, zones where electromagnetic anomalies have been documented, or where ancient anthropogenic earthworks lie buried. Even more intriguing is how rapidly termites respond to disruption. In 2011, a bioresearch station in Acre province was constructed near a cluster of unusually large mounds. Within 2 weeks of breaking ground, the structure was infested. Termites penetrated metal conduits, wooden beams, and fiber optic lines, disabling communication systems and forcing the evacuation of researchers. Subsequent investigation revealed coordinated tunneling, not random foraging, but directed attacks on support struts and foundation elements. It was sabotage, executed biologically. To dismiss this as coincidence is tempting. But termites don't navigate blindly. They follow chemical trails, respond to vibration, and, in some species, can detect the Earth's magnetic field. Their antennae and legs are packed with mechanoreceptors that can pick up micro-vibrations from meters away. Some biologists speculate that the coordinated assault on man-made structures may be triggered by disruptions in local magnetic alignment. In this framework, human construction isn't just inconvenient, it is ecological interference, and the termites respond as correction mechanisms. This invites the disturbing possibility that termite colonies, at least in the Amazon, are more than just survival engines. They may be regulators, biomechanical masons designed to maintain specific environmental or energetic balances. In this interpretation, their architecture becomes a kind of coding, a physical algorithm etched into the soil, ensuring that certain energies stay grounded, that certain frequencies remain buried, that certain zones remain untouched. Which leads us back to the idea of geometric containment. If specific mounds are built as acoustic resonators, and if these are located at intersection points of magnetic or hydrological flow, then perhaps they serve not just the termites, but the forest itself. Some researchers have even proposed, cautiously, that these sites function like organic capacitors, accumulating and diffusing subtle energies in much the same way ancient stone circles were designed to do. The difference is that here the builders are insects, and they are still building. Accidental destruction of such structures can lead to strange after effects. Local workers tell of machinery failing near recently toppled mounds, of fevers that resist medicine, of sudden shifts in animal behavior, birds abandoning nests, jaguars seen in daylight. Some dismiss these as coincidence. Others are not so sure. The forest, after all, has memory, and when its regulators are dismantled, the system may retaliate, not out of anger, but necessity. Within this perspective, termites emerge not as pests, but as conservators, perhaps even jailers. What they guard, what they contain, and whether they do so consciously or as relics of a forgotten directive, remains an open question. But one thing is certain: their presence is not passive. Their towers are not random. And to walk between them without awareness is to move across a field of latent architecture, coded, humming, waiting. There are places in the Amazon where the air thickens for no reason, where a path, moments ago bright with insect song and filtered light, becomes abruptly silent. The leaves seem to hold their breath. Even the wind is reluctant to pass. Here, beneath rotting bromeliads and rain-slicked roots, something waits. No sound, no movement, only a pressure, felt first in the chest, then behind the eyes. Guides say this sensation means you're close. They don't need to see it. They already know the Lachesis muta is near. The bushmaster snake, the largest pit viper in the Western Hemisphere, is a paradox. Despite its massive size, often exceeding 3 meters in length, and its reputation for lethality, it is rarely seen. It doesn't rattle like its North American cousins. It does not strike without reason. It watches. It waits. It vanishes into leaf matter with a stealth that defies logic for an animal of its bulk. And yet, nearly every experienced hunter in the Amazon has a story, not of seeing the bushmaster, but of feeling it. This sensation is more than fear. It is a physiological event. Palms sweat, limbs tremble. Stomach acid rises. One's orientation, even in familiar terrain, begins to unravel. There are reports of men freezing in place, unable to take a step forward, even when the path ahead is clear. Some vomit. Others flee, though they cannot say why. This reaction is not to sight or sound, but to something more primal, a disturbance at the threshold of perception. Indigenous elders call it snake wind, the invisible aura that precedes the serpent like an unseen current of dread. What makes this so compelling from a biological standpoint is that these reports are consistent across regions, cultures, and individual backgrounds. And while conventional science attributes this response to subconscious detection, the result of subtle cues like altered bird calls or chemical traces in the air, there is a growing body of speculation that the bushmaster may, in fact, emit more than pheromones or low-frequency movement. Some researchers are exploring whether the snake, through the unique structure of its nervous system and musculature, produces an electromagnetic field, faint but strong enough to trigger responses in nearby animals with sensitive bioelectric systems. The theory is not entirely unfounded. All living creatures generate weak electromagnetic fields as byproducts of nerve impulses and muscle contractions. But certain species, notably electric eels and rays, have evolved mechanisms to amplify these fields for communication or navigation. The bushmaster, with its dense muscular coils and unusually developed nervous system, may represent a land-based analog. Electroreception in terrestrial animals is rare, but it does exist. Amphibians and some insects have demonstrated sensitivity to electric fields, and recent studies suggest that even birds may use geomagnetic orientation when migrating. If so, the bushmaster's field, subtle, perhaps pulsing at frequencies below conscious awareness, might serve as a kind of perimeter alarm. a natural field of influence designed not just to signal presence, but to repel. From an evolutionary perspective, this would be extraordinary. The Bushmaster is not a fast hunter. It relies on ambush, patience, and precision. It spends most of its time coiled beneath detritus or buried in loose soil, emerging only to strike when prey comes within range. But this lethargy makes it vulnerable too. By emitting a deterrent field, a sensation of unease that discourages larger animals from entering its space, the Bushmaster secures its own safety without conflict. The jungle incredibly seems to obey. When it does strike, the outcome is rarely ambiguous. The Bushmaster's fangs are hinged, long and curved, capable of penetrating deeply into tissue and delivering avenom that is both hemotoxic and neurotoxic. The primary effect is catastrophic internal bleeding, a breakdown of blood vessels and muscle fibers, leading to swelling, organ failure, and death if untreated. But survivors, and there are few, report symptoms that go beyond physiology. Hallucinations, insomnia, vivid, recurring dreams of snakes, blood, and shadowed landscapes. In some cases, an enduring sense of paranoia or panic that lasts for years, an echo of fear imprinted on the nervous system. This psychological residue has not been studied in depth, largely because access to victims is rare. Treatment facilities are hours or days from most known Bushmaster habitats, and fatalities often occur before medical help can arrive. But among those who live close to the snake's domain, the belief is clear. The venom carries a kind of curse, not metaphorical, experiential. The idea that the snake is not just injecting molecules, but encoding something deeper, a message, a memory, a trauma, a rewiring of the self. This brings us to the most chilling accounts, those involving energetic paralysis. In many indigenous traditions, the Bushmaster is not hunted, only avoided. Ritual protections, including charcoal smearing and the use of specific plants, are performed before entering known Bushmaster territory. Some tribes speak of psychic shielding, methods intended to guard not the body, but the mind from the snake's influence. These rituals are often dismissed by outsiders, but their consistency across unrelated groups suggests a cultural recognition of something persistent, something invasive. It's as though the Bushmaster's presence is not confined to the material world. It exerts force across an invisible threshold. Biologically, this could relate to subtle sensory mechanisms. The pit organs located on either side of the Bushmaster's head allow it to detect infrared radiation, heat signatures, with astonishing accuracy. This allows it to see warm-blooded prey in complete darkness, mapping them by temperature. The organ functions much like a primitive thermal camera. But what if this sensitivity works in both directions? What if the snake not only detects life energy but interacts with it? The idea edges into speculative territory, but it mirrors concepts in other fields. In bioelectromagnetics, it's known that electromagnetic fields can influence human emotional states, especially when modulated at very low frequencies. Could a biological system, like that of the Bushmaster, have evolved to emit such a field, not to communicate, but to deter? A weaponized aura, evolved or encoded, capable of incapacitating intruders before the fangs ever strike? In this light, the Bushmaster ceases to be a simple predator. It becomes something closer to a sentinel, agate-keeper organism stationed at the edges of forgotten zones. There are documented cases of multiple Bushmasters occupying overlapping territories near archaeological sites, especially unexcavated mounds or unnatural stone formations. Whether coincidence or correlation, the effect is profound. a natural force field, both physical and psychological, surrounding areas that may once have held significance to cultures long lost beneath the forest floor. For those who speculate that the Amazon was once a curated ecosystem, a living biome forged by unknown hands, the Bushmaster represents a pinnacle of design, stealth, precision, deterrence, and psychological impact. A creature that controls space not through domination, but through presence. A snake that protects not just its territory, but something buried within it. As dusk folds across the canopy and the chorus of insects begins anew, the fear lifts slowly. Whatever was near is gone, or hiding again. The wind returns, birds call. But those who have felt it, that invisible pressure, that neurological invasion, never forget. The Bushmaster does not need to be seen to be known. It needs only to be felt. The canopy stretches unbroken for hundreds of miles, a living skin of chlorophyll, branches and vapor that conceals what lies beneath like a veil. But this jungle, so often romanticized as untouched wilderness, does not behave like a chaotic sprawl. It functions like a system. Not a passive tangle of trees and vines, but an actively regulating, memory-bearing network. Under the dense foliage, a code unfolds, not written in stone or ink, but in behavior, biology, and the strange intersections of perception and physiology. If the jungle is a machine, then its engineers were subtle. They did not build walls, they built animals. In this final analysis, we look back not through the lens of mythology or mysticism, but through the methodical eye of ecological pattern recognition. The evidence, amassed across 5 species, howler monkeys, black widow spiders, basilisk lizards, termite architects, and the Bushmaster snake, points not toward isolated evolutionary quirks, but toward a networked architecture, each organism functioning as a node in a larger ecological defense protocol. Start at the sensory perimeter, the howler monkey, Alouatta, whose voice does more than travel, it penetrates. A system of infrasonic vocalization designed not merely for communication, but for disruption. The physics of their call, a subharmonic frequency paired with atmospheric modulation, activates the brain's amygdala and limbic structures, not unlike the effect of a military-grade sound weapon. In isolation, this would be impressive, but within a pattern it suggests function, a perimeter alarm that destabilizes cognition before any predator or human even arrives at the central core of the forest. It is the jungle's first firewall. Then, as one descends through the sensory gate, the next system reveals itself, embedded not in voice, but in venom. The black widow, Latrodectus curacaviensis, represents more than simple danger. Its venom operates like a neurochemical rewriter, creating plastic windows in the brain's reward circuits, dismantling emotional and sensory regulation. The venom-induced euphoria and crash cycle mirrors the effect of long-term trauma imprinting, suggesting not only predation, but conditioning. In traditional knowledge systems, it's a recognized tool for softening the mind. In synthetic biology terms, it resembles a chemical override, an organic code injection to subvert host behavior. These two creatures work in tandem, perception manipulation followed by neurological hijack, but they are only the outermost defenses. The basilisk lizard, Basiliscus basiliscus, operates in a different domain, terrain encryption. Its capacity to run across water is often admired, but rarely understood in the context of ecological flow. The creature's locomotion manipulates the physical interface between terrain and life, a behavior that resists natural law unless viewed through the lens of surface tension exploitation. limb frequency resonance, and adaptive fluid dynamics. The terrain in which it thrives, ephemeral, shifting riverbanks, reinforces the idea of a terrain-layered barrier system in which movement itself becomes an encoded act. This is not just escape, it is evasion by design. In this framework, the basilisk acts not merely as a participant in the biome, but as an agent of terrain redefinition, creating zones that cannot be accessed or mapped through conventional means. Then, buried beneath the visible, both literally and structurally, we find the termite, Nasutitermis sap, whose behavior veers sharply away from instinctual burrowing and toward architectural orchestration. The symmetrical alignment of mounds with celestial and geomagnetic markers, coupled with internal acoustic properties tuned to resonant frequencies, suggests a level of spatial intelligence previously unassociated with eusocial insects. These are not homes, they are constructs, chambers of resonance, vents of pressure, nodes of containment. In rare instances, disrupting these mounds has coincided with unexplained phenomena, short-range electromagnetic failure, altered animal behavior, even mass migration of frogs and birds. Such effects point toward the termite colony functioning as geoenergetic regulators, maintaining an equilibrium not for themselves but for the biosphere. At the heart of this biome, coiled silently, lies the bushmaster, Lachesis muta. It is not the apex predator in terms of biomass or dominance, but it serves as the sentinel, the final layer. Its presence is felt before it is seen. Physiological reactions to the bushmaster's presence, tachycardia, paralysis, confusion, occur even in the absence of visual confirmation. Theories suggesting an electromagnetic field surrounding the snake, generated by its dense musculature and nerve system, are supported by anecdotal reports of sensor disruption and animal avoidance. The bushmaster does not simply kill, it warns, it infects perception, it disables action. And once it strikes, the venom it delivers is not just fatal, it leaves behind a residue, psychological, dreamlike, persistent. Survivors are rare, but they describe symptoms more commonly associated with PTSD or spiritual possession than with conventional envenomation. In system terms, this is energetic encryption, a final security lock. Viewed collectively, these 5 organisms illustrate a multi-tiered defensive protocol embedded within the rainforest itself. A sequence: sensory disruption, howler; neurochemical subversion, black widow; terrain obfuscation, basilisk; environmental structure control, termites; energetic gatekeeping, bushmaster. Each organism protects not only itself, but a territorial function. Each introduces a unique form of interference that escalates the further one presses into the biome. And this interference is not random. It is consistent across geography, climate gradient, and altitude, suggesting it is not evolved, but implemented. The implications are stark. If the Amazon is not merely a wilderness but a living infrastructure, then the animals we study are not just ecological phenomena. They are living subroutines, coded in DNA but interacting in emergent ways. Sensory feedback loops, energy dampening fields, terrain manipulation systems, and possibly more we have yet to detect. The biosphere behaves like an operating system, and these species are its encrypted modules. What does this mean for humans? The worst-case scenarios are not about bites or scratches, they are neurological and spatial. Cognitive erosion. Prolonged exposure to infrasonic or venom-based stimuli may disrupt memory, sleep, and identity, slowly eroding logical thought. Energetic contamination. If organisms like the bushmaster or the widow alter the vibrational baseline of the human nervous system, it may result in disconnection from normative biofields, resulting in illness, disorientation, or psychic breakdown. Geospatial disorientation. The terrain is not neutral. It restructures itself through creature influence, termites shifting landforms, basilisks destabilizing pursuit vectors. GPS fails, maps decay, memory loops. Neurochemical hijack. Emotional and behavioral pathways can be overwritten, not merely chemically, but through exposure to resonance, vibration, and encoded movement patterns. It is not just a jungle, it is an interface. Some researchers, reluctant to publish for fear of ridicule, have begun mapping not just habitats but intersections, zones where the effects of these 5 species overlap. In every case, these intersections occur near known anomalies, archaeological ruins swallowed by foliage, unexplored cave systems, unnatural mound formations. One geophysicist even noted that patterns in termite nest geometry matched frequency harmonics used in ancient temple acoustics across Mesopotamia and Angkor. Coincidence or convergence? The final unanswerable question remains. To what end? Were these species created or nudged by a forgotten intelligence? Are they guardians, programs, systems of defense left behind by a vanished biomechanical culture? Or are they locks, keys twisted into living form to hold back something deeper buried beneath the forest floor? We may never know. The data is fragmentary. The jungle, as always, reveals little. But those who spend time here, who feel the shift in perception, the pressure before a sound, the dreams that echo too vividly, they understand. Something is being maintained, a balance, a code. The forbidden code is not extinct. It is alive. It moves beneath the leaves. It sings from the throats of monkeys. It dreams through the eyes of venom-bitten survivors. It speaks in the geometry of insect mounds and the vanishing footfalls of lizards across rivers. It waits, not like a predator, but like a system still running, still listening. And if we decode it, if we trespass too deep, we may not just find knowledge, we may trigger it.